Welcome to today's keynote. I like to talk a lot about software design and especially about how to take things from other designers into our own practice. But before we start going into this, I need you to get into a special mental place. Because you probably all come here from, stressful jobs and you have a lot of things to work with. And what I'd like you to do is, we cannot have this discussion unless you are, let's say, more relaxed and more open. So what I like to ask you in the beginning of this talk is to take a few seconds and think, when was the last time we actually enjoyed programming? And we are going to build upon that. Cool. Somebody said yesterday. Who enjoyed programming yesterday? Excellent. Okay. Thank you. So it's very interesting to me that this is actually a sequel. I did a few years back a keynote at T.A.K.E. Unconference, which was called What is Good Software Design and Why It Matters. I won't go into details. You can find the talk online. But I will summarize what we turned up with. And at the end of that session, what we ended up with is that in order to obtain good design, we need at least three things. One is process. We need to have a good design process. Another one is good designers. Because as much as you'd like to think that, TDD can get you good designs, that's not true. It's actually the people who get good designs with the right process. And there's one underlying thing, which is having intent. Whenever you do something in your code, make it very clear, very intentional. And today I'm going to focus on the idea of good designers and what it means to have good designers. So just a quick raise of hands. How many of you think of yourself as designing code? Okay. How many of you design other things? UI, UX, visual? Okay, interesting. How many of you know designers from other domains? Nice. So you can have a lot of interesting conversations with designers from other domains. I started calling myself a code designer, and the reason is I believe this gives me perspectives. This gives me a few interesting perspectives about what I'm doing every day. And the first perspective is, I believe that we solve problems. I just happen to use code as a material for prototyping solutions to those problems. This is my material, the one that I know best. But what I'm really doing is I'm solving a problem. And this is what other designers are doing as well. The second perspective is that if you think of yourself as a designer, you realize that there are 40, 50 different types of design out there, at least. And you can learn from those other people. You can learn from how they do their own work. And the third perspective is that design is a very old discipline. To give you a perspective again, we can say that the Egyptian pyramids were designed. Right? This is thousands of years ago. Software development is a fairly new industry. It is very arrogant to think that you cannot learn anything from the other designers, the other people who, these disciplines that developed in many, many years. Before we move forward, this is not a talk about these things. They are all very important. I highly encourage you to know clean code, test-driven development, refactoring, domain-driven designs. These are all really good. But what I'm more interested in is going beyond them. So, as I mentioned, there are a few things. So before we can go into talking about what good designers are and how to get to good designers, we need to touch a bit on the process. And I have my personal story, because 17 years ago, I was in France working for a customer. I worked there for about 1 year. I was a young developer. I read a lot of books on object-oriented programming. I used to read the first chapters of all the books on OOP languages just to get a better understanding of what OOP is. And I have to say that I still failed at software design. I failed really badly because at the end of the 1 year project, I realized I had coupled the database with the user interface. And it took me 1 year to figure that out. And the way I designed back then was I got a task, and then I would fiddle with code until something worked. And I would say, okay, I'm done. Guess what? I got back bugs. I got back, it was difficult to change the code. I would change the code in one place. It would blow in 10 other places. And this was my process. How I usually design today, I understand now that I got into this cycle of, writing tests and doing test-driven development. I understand much more about software design. But even with this, of course, I still get bugs, but fewer than I used to. But what's interesting about this is that there's a certain assumption behind this. There's an assumption behind this process that on each step, you pick some solution that makes sense in that context. And how do you pick that solution? By having a certain taste for design, a certain intuition for design. You cannot obtain, even with TDD does not lead to good designs. People who use TDD can use it to get good designs. And the issue is that in any other design domains, what we call intuition, what we call taste, has another name. It's called satisficing. Satisficing is a process in your brain that says, because your brain is very lazy and because of evolutionary concerns, so if you are in a jungle and you see a yellow, large thing coming fast at you, you don't think about all the possible animals it could be. You just run away. So your brain just fits the first simplest solution that it can find. And this is something that other designers struggle with. And they actually train to go beyond this satisficing thing. If you only come with one solution, this is the challenge that you have as a designer. No other designer from no other industry would come with only one solution. And so how do other designers design? It's an interesting thing here because they try out various solutions and they do prototypes. And just to make sure, because there's a lot of vocabulary in software development that relates to manufacturing. But actually what I'm talking about is not manufacturing. I'm talking about what's happening before you actually start manufacturing. I'm talking about writing the designs. And in our case, the code and the code structure, this is what the design is, because you build when you click the build button or when you run the code. So, as I mentioned, I learned software design by making a lot of mistakes. That was one of them. There are many other mistakes that I've made in time. And I started recently to look at how other people learn design. And it turns out that there are two techniques, two things that I will talk about, design studies and design schools. So the thing is, can we have the same? Can we use the same things for us? And before I can go into explaining what design studies are and why they are so useful in any other design discipline. What I'd like to explain is that it's important to make visible to yourself how you make the design decisions. Because maybe you don't believe me that you just pick, the first solution that fits. And so we experimented with a pair programming format, which is called driver documenter. And the idea here is that you have one person, the driver, who writes the tests, writes the code, refactors. And whenever they stop, the documenter will start asking them questions. Questions like, what other solutions have you considered? What made you pick this solution over the other? What were the alternatives? And in doing so, you build this map of decisions. So in the center you have, this is a mock-up, by the way, because unfortunately we threw away our experiment papers. But in the center you have the decisions that the driver picked, and on the left-right side you can have the other possible ideas. And you can also document why you pick a certain solution. What were the reasons behind this? I have to warn you, this is a very annoying style of pair programming. It's not meant for production. It's meant to understand how you make design decisions. It's very slow. It can take 1.5 hours for a few tests, but it is annoying good because what it makes is that you suddenly start to understand why you make certain decisions, where they come from. So I highly encourage you to experiment with this. With a friend, because if you do it with somebody you don't like, it won't be that nice. So. And so, if you get convinced by this idea that, maybe I should look into other design alternatives before jumping to one solution, a way to do this is design studies. And before I can go in design studies, I will tell you a little story. I like to travel a lot. It was very fun for me to put on a map all the places where I've worked. And recently, my work took me to the city of Copenhagen. And many people, I assume if they go to Copenhagen, they like various things, like the new port or touristic attractions. What I liked was this building, which is the Design Museum from Copenhagen. And it turns out when you go there, one of their big collections is a collection of chairs. Who would have thought that chairs are so interesting? But if you look at it, chairs, and this is actually a hall where you can walk and you can drag the designs for all the chairs. It's very educating. But chairs actually are a very interesting type of object because we all know what chairs are, but they are very difficult to design. You need to take into account a lot of variation. You need to take into account, how heavy a person can be, how tall they can be. Do they want to hang stuff on the chair or not? Do they want to move the chair? There's a lot of things there. And so it turns out that many of the design currents, actually one of the things they do to show their ideas is to design a chair. And I'm just going to show you a few different chairs. So you see the first one is very heavy, looks, it tends to project power. The second one, this one is 1945. They didn't have a lot of material. They had to cut down on all the things that were necessary. And you can see all the different designs and how some of them they try to make from one piece and others are very easy to assemble or to change. There's this one that I like a lot because the designer said it's more fun to sit on a color you love, and that's why they made it red. And a very modern one, very simple, clean colors. And then a fun one. It's sneaky. It tries to steal stuff. And one of the most interesting parts of the museum is this picture that shows all the possible variations, just the sketches of all the possible variations of a chair. This is what a design study is. It's looking at the problem, but then figuring out, depending on various constraints, on various styles that you pick, what are the different variations. And designers do that when they learn their job, and they do that even for production, even for customers. So what would be the idea in a software design studies? The idea would be to take a realistic problem, so not a kata problem, not a simple thing. Take a more realistic problem, something that is close to production, implement a part of it, not the full extent, because nobody has time to implement, all the possible variations to production problems, but just enough to give you more insight on how you can structure your code. And you need to take these solutions further than a kata. So it's not just a small thing. It probably takes a bit of time to get there. And I will show some examples from what I did. I identified two types of design studies until now. One was that I've done. One is comparing specific techniques. So for example, I want to see what's the difference between immutable and mutable code, or functional versus object-oriented, or things like this. So I would take the same problem and try to implement it with different programming techniques. And another one is, what if you go all the way for a certain design quality? So what if you go all the way, make the most performant implementation, or make the most scalable, or make the least memory consuming? And see how this changes your implementation. And I will go in the examples just to know. I started adding all of these on the website codedesigner.eu. So if you go there, you'll find links and blog posts and all that, just to have one place where you can find those. And if you'll follow me on Twitter, I'll notify when I publish new things there. So one of the design studies that I did was starting to implement Pacman. Now, I implemented Pacman in the past using a normal TDD with object-oriented approach. But I started this as an experiment with immutability and pure functions. So I wanted to do this completely pure functions. And then it was very interesting that I did it using TDD as if you meant it, and I started from example-based tests, and then I moved into data-driven tests, and then they turned into property-based tests. And if you were yesterday at Pedro's session, you saw what property-based tests are. But basically what these tests say is that you have a line that has an arbitrary number of dots, and then here, arbitrary number of dots. You have a Pacman that's turned to the right, and then you have at least one dot afterwards. And what you expect is that your Pacman will move to the next step to the right. And this works for an arbitrary number of dots in the line, right? But I didn't get there by writing these properties first, but by just refactoring. So that was a very interesting experiment to me. I learned a lot. Then I tried to rewrite this for C++, because I was very interested to see how you can use the new functional programming features in C++. And what's the difference with the other languages, with Groovy or... And it turns out that I had to write some more helper methods, because it didn't quite work as simple as I expected, especially allocation. So just to do transform, which is basically a map in other languages. You need to also take care of allocating memory. Another case study that I've done is, and this is very interesting, if you want to understand how far you can go with functional programming in a language, there's this thing called church encodings. Church encodings have absolutely no practical value from my point of view right now. But it's a way of writing all the types as functions. So you can write true, false, if, and actually also the numbers as functions. What I wanted to understand is, can I do this in C++? And it turns out that, except for a bit of a syntax strangeness there, it is quite easy to implement. And it looks nice. I didn't expect that. It was I was expecting much more complex code. Another design study that I did started from the idea of composability. So can I compose functions? Can I put functions together? Can I do query? Can I do all kind of the functional programming things? And there are a few things here in Groovy that I don't really like. So for example, this method call, it binds the Alex string to this function, to this lambda, to the first parameter, the first name. I would have preferred to have a named parameter there, but that's how it works. It's not very clear. And to make it even more confusing, they have a query write, which goes the other way. So you need to remember all these strange things. And I wasn't the only one doing this. I looked at, found an article on the web, Hacker Noon. It's a really nice website. If you don't follow it, I would encourage you to do. And what this article is about, it's about the various state management systems for React. So React doesn't have state built in, so then you need to add a bunch of things for state. And of course, Redux is one of the ways. And Aline will say differently, but but what you can see there, it's actually a comparison of, I think, 15, 20 different state components for React. Again, it's a design study because it shows you how you can do this in very different ways. Another thing that I've done is, I've always thought that, we are talking about microservices, but my first idea when I heard about let's have small programs that run as services, and that's another iteration of Unix processes. And I thought about doing this design study, and all these are on GitHub, where we have actually self-contained processes instead of microservices. Because if you think about it, why do we have, so if I'm Netflix, if I'm, these large companies, I understand. You need to have a lot of performance, a lot of scalability, and so on. But if you just start with microservices, why do you need to have it as a service? And I still feel that services are really heavyweight things right now. So in order to write a simple microservice, you need HTTP, you need JSON, you need a lot of things like this. So I wanted to explore the idea of having, instead of microservices, what if we write simple programs that can create their own database, that can test themselves. So you can actually call this and say self-test. It will run all the tests. It will tell you, yeah, I'm working fine. They can, remove the database and so on. And one of the things that I found out is that it's quite difficult to, it's not very nice to communicate between processes right now. You can use pipes or things like this. Not very nice. But if we had that communication mechanism closer to something like the easiness of what we have with JSON, REST, and so on, I think it might make a lot of sense. Yeah, and this is still a work in progress. What I'd like to do with this is to actually test how much of a difference it makes. So when does it make sense to actually have a service? Because a service, what it does is basically just caches stuff. It caches your database connection, it caches your, I don't know, file descriptors, whatever else you need. But if you don't use that service very much, my assumption is that the performance is not impacted. It might actually be faster to just start a service, process whenever you need it. So this is more on the architectural side, let's say. And I'd be very interested to see this in other technologies as well. So then, what other ideas are for design studies? What could you use for yourselves? And one of the ideas is, I've done this in the past, so for example, an XML parser or HTTP or JSON, doesn't matter. Pick one of the languages. And just pick a subset of features. So it doesn't have to be a full-fledged, XML parser because it gets really boring after a while and really repetitive. But just have a minimum amount of features and then pick one of the, for example, quality constraints. So how about if we need to have as low memory footprint as possible or have it as fast as possible? Only if you take these two things, it will change. It might change a lot your design. So by doing so, you learn various ways of structuring your code. And then you also have the advantage that you can compare your implementation with the ones that are already there, that are open source. You can look at them and say, okay, why do they do that? Why do I do that? Another idea, and I've actually worked on this a few years back, in 2002, I was in a project where we basically developed a NoSQL database engine before there was NoSQL. And we wrote that in C++. And what is very interesting about this problem is, again, you don't have to implement full-fledged. You don't have to implement SQL support. That doesn't make a lot of sense, unless you really like it. But a minimum amount of features just to see how you can, store data, write, update, find, things like this. And then try to see what's the difference between fast reads and fast writes, for example, because it's a completely different way of attacking the problem. Or parallel access, very interesting problem for databases. Gives you a lot of information on how to do parallel programming in other cases. And again, you have existing implementations. You can look at those and say, oh, how does MySQL does this? Even if it's a very small thing. Another one that I really like is, I like to use games. And I've done Tetris a number of times. When doing Tetris, when doing games, it's very interesting that you have a few basic things that are in any game. You have a game cycle, you have collision detection, you don't have AI, which is good because that's a more difficult problem. But you have a lot of the basic elements of a game. And one thing that you can strive for is changeability. So what if we can make a Tetris engine and then you can plug in a console-based UI or a Java FX UI or an OpenGL UI, but have it as a plugin instead of going straight for it. And of course, another option is to look at performance and just optimize for performance. Forget about the changeability stuff. Focus on how you can make the highest FPS and just maintain it. So there are a lot of ideas for this kind of practice things. And we wrote more of them. Again, this link is somewhere on codedesigner.eu, and you can go directly here. There are more ideas there. It's still a work in progress, but it's very, if you have any suggestion, if you have any ideas, if you have any problems that you like, I'd like to document them. So this is what a design study is, and this is how we can use a software design study to, again, expand our intuition. Because our intuition tends to be very focused on the experiences that we had before. And sometimes we need to focus on, expanding. That's when you'll make more decisions, more good design decisions. The reason is any decision in software design is contextual. So you saw that we already discussed about things like, what if we have only little memory? What if we want changeability? These are two completely different problems. If you want to fully optimize for one of them, you'll get very different results. And that's why it's worth going there. And again, how do designers learn these things? They usually combine them in design schools. So just to simplify, in design schools, what you usually get is a workshop on a specific technique. And then you get some design studies to do, and you have to come up with more solutions. Right? In many cases, they come up with 20, 30 different solutions and discuss them and see what are advantages, disadvantages for each of those in order to expand your intuition. And what a design school is, it's also a community. It's not only a place where somebody teaches you, but it's also a place where you practice and share. So there's no such thing for software design until today. We launched this software design school, and you can find more information at our booth. And the idea is exactly this: focus on, design studies and a community and workshops. And like any design school, if you go to a certain design school, they will give you advice for a specific set of qualities. Each design school is opinionated. They believe in a certain techniques, in certain values, and what we believe in is simplicity and fast delivery. These are the things that we focus on. So if you want to do very scalable applications, hopefully there will be another design school for that. This is more for simplicity, fast delivery. Quick recap. So if you've been asleep until now, this is your chance to get all my talk. Design is a very old discipline. It has a lot of variations. It is arrogant to think that we cannot learn anything from other designers. What we are doing is design. We are not building stuff, because the build happens when you push the build button. And we have one big advantage, that our build is fast. If you want to design a car and to build it, it's not as fast as writing some code and building it. We can learn from other designers, and one thing that, if you learn one thing from here, is that no other designer comes with only one solution for a problem. They always come with multiple solutions. But in order to get there, you need your intuition. You need to go beyond satisficing. And this will force your brain. It's not an easy process. You need to force your brain to see beyond the things that you are used to. And I propose to you three different things that you can use. First, in order to understand your intuition, try the driver documenter approach and see why you make certain design decisions. Second, to expand your intuition, design studies, and you have a list of those. And third, join a design school or build one, why not? So you can find out more on codedesigner.eu, and at our booth. I've been Alex. I'm co-designer. You can find me on Twitter at Alex Bolly. And check out my book about applying UX principles to improve the lives of other programmers when you write your code. Thank you.
Thank you. So maybe we do have time for 1 or 2 questions, if anybody has any and wants to address them publicly. Okay. Then thanks again, Alex.
Thank you.